Good morning, everybody. Today we are going to solve the practice problem 3.5 from Fundamentals of Electric Circuits by Alexander Sadiku. This problem is based on mesh analysis, and so we apply KVL to solve this problem. Kirchhoff's voltage law states that sum of all voltages, that is voltage rise and voltage drops, in a closed loop is 0. Also, we apply Ohm's law, that is V equal to IR. So, this is the circuit drawn by us. So, we are going to use mesh analysis. And in this, what are all the things already marked in the problem itself? And what are all the things given? See here, we have the 45 volts voltage source and 30 volt voltage source available, and 2 ohm, 9 ohm, 4 ohm, 3 ohm and 12 ohm resistors given, and then this I1 and I2 currents are marked. The voltage sources represent voltage rise and its polarity changes from this minus to plus, and the resistors, they have the voltage drop, so the polarity changes from plus to minus. See here, this would be plus when the current flows through that, and this side will be minus. So this loop goes through this, and then here it is going through this. So the current flows through this path. Similarly, it goes through this path, and then it goes through this path. Finally, it ends at this. Okay. So you have a closed loop through which the current I1 is flowing. So when current I1 is flowing through this, here it is minus to plus, and here it is voltage drop, so it is plus to minus. Again, here also it is voltage drop when the current I1 is flowing, so it is plus to minus, and here when it flows through that, it is plus to minus. At the same time, if you consider this 12 ohm resistance, the I1 current is flowing, similarly the I2 current is flowing. When you see the I1 current is following this path, at the same time this I2 current is flowing in this direction, opposite direction. So what happens, it is voltage drop in this direction, so that here you have this plus, and on this side you have minus for this I2 current. So this is loop 1 and this is loop 2. For this loop 1 or mesh 1, we will write the equation now. So it is minus 45 volts plus this 2 ohm resistance through which this I1 current is flowing. Since it is voltage drop, it is plus to minus, so we write it is 2, that is Ohm's law is applied, so 2 into I1. Then again it is flowing through this path, that is through this 12 ohm resistance, in which two currents are flowing here. So I1 is flowing downwards, at the same time this I2 is flowing upward. Okay, so we have plus 12 I1, and then I2 current is flowing in the opposite direction, that is minus. Okay, minus 12 I2. Then it comes to this path, that is the current I1 is flowing through this 4 ohm resistance. There also it is voltage drop. So we take it as plus 4, that is the Ohm's law, right? 4 I1, that is equal to 0. So now we rewrite and adding all the I1s together. So you'll get this as 2 I1 plus 12 I1 plus 4 I1, that is equal to 18 I1 minus 12 I2, that is equal to 45. So this is your first equation, equation number 1. So for loop 2, we can take it as it starts at this point. Okay, so the current I2 will be flowing through this path, through this 9 ohm resistance, and then it takes this path in this direction, then it is going through this 3 ohm resistance in this way, and again it is flowing through this and reaches this point, completing the loop. Okay, this is the direction of I2. And here, so this I2 flows through 9 ohm resistance, 3 ohm resistance and 12 ohm resistance, but this 12 ohm is common to this I1 also. Okay, that means first loop also. So for this case, if you mark the polarity for the 9 ohm resistance, it is plus to minus because the current is flowing in this direction. Similarly, for this 3 ohm resistance, this end is plus, this end is minus. Okay, and 12 ohm resistance also, here you have plus and minus. We apply the mesh analysis for loop 2, 9I2, then here it is going from plus to minus for 30 volts, so it is plus 30. So when you go through this path 3 ohm resistance, then it is also plus 3 ohm resistance into that current I2, then that current will be flowing through this 12 ohm resistance. So there also you encounter this plus sign first, so it is plus 12, that I2 current is flowing through that. Similarly, the I1 current is also flowing in the opposite direction, so it is minus 2 plus for this I1, so you have to write this minus 12 I1, that is equal to 0 for the closed loop. Okay, now we combine all the I2s together and I1 together, so we'll get this as minus 12 I1, then plus 24 plus 24 I2, that is equal to minus 30. So multiplying this by minus, I'll get this as 12 I1 minus 24 I2, that is equal to 30. So now we'll get the second equation. So using elimination method, we try to solve these two, first equation and the second equation. So multiply equation 1 by 2, we get this as 36 I1 minus 24 I2, that is equal to 90. So you can take this as equation 3. Now, so we are going to apply the elimination method for second and third equation. So by changing the sign for the third equation, we will take this as minus sign and this becomes plus and this becomes minus. Okay, so these two get cancelled, so that you will get this minus 24 I1, that is equal to minus 60. So you can rewrite this as 24 I1, that is equal to 60. Okay, I1 is equal to 60 by 24. So I1 is equal to 60 divided by 24, that is equal to 2.5. So we get the answer I1 is equal to 2.5 amps. It's the correct, we got the answer for this. So this is the first answer we get. Substitute this I1 in equation 2. So I get this as 12 into 2.5, that is the I1 value, plus, sorry, minus 24 into that I2, that is equal to 30. So this is 25 into 2.5 is 30, then minus 24 I2, that is equal to 30. So 24 minus 24 minus 24 I2 is equal to 30 minus 30, so it is 0. So we got this I2 as 0. So this is our second answer. So to summarize, we get the answers as I1 equal to 2.5 amps and I2 equal to 0 amps. Now we'll verify the answers. So the answers given in the book, so it is 2.5 amps and I2 0 amps. So hence our answers are verified. Thank you.